Hey everyone, welcome back to the channel. If you've ever thought about getting certified in machine learning, today's video is going to be super helpful because we're diving into the Databricks Certified Machine Learning Associate exam. First off, the exam assesses your ability to perform basic machine learning tasks in Databricks, not just theory. That means you need to know how to explore data, perform feature engineering, build and tune models, evaluate them, and finally deploy them. It's all about being able to work with Databricks ML capabilities like AutoML, Unity Catalog, and MLflow. For the number of questions, it's 48 scored multiple choice or multiple selection questions, which is manageable if you pace yourself. That's why knowing the exam length and time limit, 90 minutes, is so critical. You want to make sure you're spending the right amount of time per question. Registration fee is $200, say. Recertification is required every 2 years to maintain your certified status. To recertify, you must take the current version of the exam. Please review the Getting Ready for the Exam section below to prepare for your recertification exam. Python is your go-to language, so brushing up on Python libraries like scikit-learn or SparkML will pay off. Don't worry if you haven't used other languages like Java or Scala in ML tasks. Python is what they're testing. Now, Databricks recommends a mix of instructor-led and self-paced training. Let's start with the instructor-led option. There's a course called Machine Learning with Databricks. This is great because it's hands-on, interactive, and you get to work through real-world examples with guidance from an instructor. Think of it as a way to get a structured roadmap and have someone point out the pitfalls before you hit them yourself. Next up, self-paced learning. Databricks Academy has a bunch of really useful courses that you can do at your own speed. First, there's data preparation for machine learning. This is all about cleaning your data, transforming it, and making sure it's ready for modeling. You'll learn feature engineering, handling missing data, and working with different data types, basically everything you need to make your model work properly. Then there's machine learning model deployment. This is huge. It's not just about building a model, it's about getting it out there where it can actually make predictions and provide value. You'll learn how to deploy models in Databricks, manage versions, and ensure everything runs smoothly in production. We also have machine learning model development. This is where you focus on building, training, tuning, and evaluating models. You'll learn how to select the right algorithms, optimize hyperparameters, and assess model performance. This is basically the heart of ML work in Databricks. And finally, there's machine learning ops, sometimes called ML ops. This is all about operationalizing your machine learning workflow. How do you monitor models, handle drift, automate retraining, and maintain production systems? This course gives you a framework for keeping your ML pipeline robust over time. Now hang on, because this part's super important. You can't just rely on courses. You also need hands-on skills. That means a working knowledge of Python and major ML libraries like scikit-learn and SparkML. You'll be writing code, training models, and running inference in Python, so being comfortable here is key. On top of that, you'll want to know Databricks-specific tools like Unity Catalog for managing data and Delta Live tables for creating pipelines. These are integral to how Databricks handles data management and ML workflows, so familiarity here will save you a lot of headaches. And last but not least, take some time to familiarize yourself with the major topics in Databricks machine learning documentation. Even a quick read-through can highlight areas you might not have practiced yet and give you confidence going in. So what does this really mean for you? If you're aiming for this certification, focus on hands-on practice, understand the ML workflows in Databricks, and make sure you know your way around AutoML, feature engineering, model evaluation, and deployment. Remember, it's not just about memorizing facts, it's about being able to actually do machine learning tasks end-to-end in Databricks. All right, that wraps up our walkthrough of the Databricks Certified Machine Learning Associate exam. Let's dive into the exam prep first question. Today, we're talking about the gold layer in Delta Live tables and why it's such a big deal for streaming inference. All right, let's look into the first question. Here it is. Why is the gold layer, also known as the inference table, critical in streaming inference with Delta Live tables? Here are your options. A, it stores the output of model predictions and allows downstream analysis or monitoring. B, It performs initial ingestion and schema validation of raw streaming data. C, it applies feature transformations to raw data before model application. D, it automatically scales Spark executors for processing incoming data streams. Take a moment and think about that. Which one do you feel makes the most sense? Gold layer plays a very specific role in the whole streaming pipeline. You might be wondering why we don't just do this in the bronze or silver layers. Let's break that down together. The bronze layer is all about raw data ingestion. It's messy, it's unprocessed, and it's exactly where we want our original stream to land without any assumptions. Then comes the silver layer, which applies transformations and feature engineering. So by the time data reaches the gold layer, it's been fully prepared for the model, and the predictions generated are stored in a clean, structured format. Imagine your streaming data is flowing in like a river, maybe from Kafka, Kinesis, Event Hubs, whatever. Where does it land first? That's right, the bronze layer. Think of bronze as the landing zone. Raw JSON, Avro, maybe some messed up records. Everything gets ingested as is. No cleaning, no judgments, just come on in, we'll sort you out later. Now, once the data is safely in bronze, we push it over to the silver layer. This is where the magic of cleaning and feature engineering happens. We dedupe, we parse nested fields, we join with lookup tables, we calculate rolling windows, lags, all the good stuff your model actually needs to make a prediction. By the time data leaves silver, it's basically model ready. Okay, so we've got clean, transformed features streaming out of silver. Now what? Here's where most people get a little fuzzy, and this is exactly why the gold layer is the hero of today's story. As each micro batch of features comes flying out of silver, Delta Live Tables picks up your registered MLflow model or Unity Catalog model, runs the inference in real time, and writes the results where? Straight into the gold layer. This gold table is literally called the inference table for a reason. Every probability, every timestamp, input features if you want them, model version, everything lands here in a super clean, queryable Delta table. You might be wondering, okay, but can I just read the predictions directly from the pipeline? Why do I need a whole separate table? Hang on, because this part's super important. If you don't have a dedicated gold inference table, every dashboard, every monitoring job, every alert you want to build has to rerun the scoring logic from scratch. That's expensive, slow, and honestly a nightmare to maintain. But when you materialize the predictions into gold, boom. Now your Power BI dashboard can just do a simple select file from gold.inference table where prediction date equals today. Your model monitoring job can compute drift against ground truth with a single join. Your business team can build real-time leaderboards without begging the data team for a new pipeline. It's the difference between, hey, can you score this again? And it's already there. Just query it. So option A talks about storing model predictions and supporting downstream analysis and monitoring. This is exactly what the gold layer is designed for. Think of it like a clean, polished final product. The predictions are ready to be consumed by dashboards, reporting tools, or even other systems. Without this layer, you'd be trying to make sense of raw or partially processed data, which could be messy and unreliable. The gold layer gives you a single source of truth for your inference results. So, looking back at our options, B is classic bronze behavior, raw ingestion. C is what silver does all day, feature engineering. D, yeah, DLT and Databricks auto-scale the cluster for you, but that's not the gold layer's job. That leaves us with A, and honestly, once you've built one of these pipelines in real life, you'll feel how true this is in your bones. Quick recap before we wrap up. Bronze equals raw landing, silver equals clean features, gold your golden source of predictions that every downstream system loves to consume. Now, option B says the gold layer performs initial ingestion and schema validation. That's not correct because, as I just mentioned, that's the bronze layer's job. Raw ingestion and validation happen before any modeling even begins. Option C says it applies feature transformations. Nope, that's the silver layer again. The silver layer is where you clean, enrich, and prepare your data for the model. The gold layer is purely about the results of inference. And option D, automatic scaling of Spark executors, well, that's handled by Databricks infrastructure itself, not by the gold layer. So while Spark does scale to handle streaming workloads, it's not the gold layer doing that work. So what does this really mean for you? If you're building real-time ML pipelines, understanding the role of each layer is crucial. The gold layer is where your model predictions live, ready for downstream analysis, dashboards, monitoring, and even further ML operations. It's your clean, trusted output that lets you actually make decisions in real time. Remember, bronze is raw, silver is transformed, and gold is inference ready. All right, that wraps up our deep dive into the gold layer in Delta Live tables. If you're working with streaming data, keeping this layer in mind will save you a lot of headaches and make your pipelines way more reliable. Let's look into the next question. We're going to walk through a really important concept, baseline model generation using Databricks AutoML, and why it matters way more than most people think. All right, let's look into the second question. Here it is. A company uses Databricks AutoML to create baseline models before customizing them further. Why is baseline model generation important in this process? And here are your options. Option A, it provides an initial reference point for comparing advanced custom models and identifying improvement areas. Option B, it directly generates the final model for production deployment without further tuning. Option C, it eliminates the need for evaluation metrics since baseline models guarantee high accuracy. Option D, it replaces feature engineering with random feature selection for quick prototyping. All right, take a moment. Think about which one feels right to you. Don't worry, we'll walk through it together. So picture this. You just dropped your data set into Databricks AutoML, you hit run, and boom. In like 20 to 30 minutes, you've got a fully working model with pre-processing, feature engineering, and even a leaderboard of different algorithms. That first model that pops out, that's the baseline. And here's the thing. A lot of people think, sweet, I'm done. Nope, not even close. That baseline is literally the starting line, not the finish line. Let's walk through this flow chart together because this visual is gold. We start on the far left, raw data goes in. AutoML automatically does all the boring stuff, cleaning missing values, encoding categories, scaling, all that jazz. Then it runs smart feature engineering. Nothing random, by the way. It's actually pretty clever. From there, it spins up multiple training pipelines, does cross-validation, and hands you a baseline model with real metrics. Accuracy, AUC, RMSE, whatever your problem needs. Now, here's where the magic happens. Look at all these arrows pointing back to compare with advanced models. That's the entire point. Every single custom thing you do later, whether you're building crazy new features, stacking models, doing hyperparameter tuning for days, you're going to keep coming back to this baseline and asking one simple question. Did I actually beat the dumb automated version? And you'd be shocked how often the answer is no. Like you spend 2 weeks handcrafting features and your custom XGBoost barely edges out the baseline that took 0 brain cells. That's the moment you go, okay, maybe I'm over-engineering this. Or the opposite, your custom model smokes the baseline by 15%. And now you know exactly where your effort paid off. Without a strong baseline, you have no idea if you're actually making things better or just chasing your tail. It's like trying to lose weight without ever stepping on a scale. You might feel like you're working hard, but you don't know if it's moving the needle. So yeah, A is the winner, hands down. The baseline is your North Star. It's the what's possible with almost 0 effort benchmark. And honestly, in real projects, I've had stakeholders try to ship the baseline straight to production because it was already good enough and we were on a deadline. That's how strong these things can be. A baseline model is not, and I really mean not, a final production model. That's why option B doesn't hold up. B says it gives you the final production model. Nah, that's not true. Most baselines still need guardrails, fairness checks, drift monitoring, all the grown-up stuff. AutoML isn't magically delivering a fully battle-tested model that you just ship out. You still need tuning. You still need validation. You still need to think like a real data scientist or ML engineer. Then we have option C, which suggests that baseline models somehow eliminate the need for evaluation metrics. That one's a big no. You always need evaluation metrics. Baseline models don't guarantee high accuracy. They just give you a starting point. And what about option D? Random feature selection? Nope. AutoML actually performs systematic feature engineering. It's not tossing in random features and hoping for the best. It's using smart heuristics and pre-processing steps to build a pipeline that makes sense. So circling back, the option that really captures why models matter is option A. They give you that initial reference point, that comparison anchor, that diagnostic checkpoint that tells you how much better your custom models need to be. And here's something a lot of people don't realize. Baseline models also speed up experimentation. Instead of starting with a blank notebook, you start with a full pipeline. You can refine it, extend it, adjust it, but you're not building everything from scratch. That alone can save hours, sometimes days. So there you have it. Baseline models aren't just simple automated outputs, they're strategic tools that guide your entire machine learning workflow. They help you assess your dataset, speed up development, and create a measurable standard for improvement. Let's look into the third question. This one's really interesting because it mixes concepts of feature store, external columns, and batch inference, all in one neat scenario. Here it is. A model trained with Databricks feature store references both feature tables and additional columns, such as browser, that exist outside the store. During batch inference, which of the following statements correctly describes the requirement for using the model with the score batch API? And here are your options. Option A, the data frame used in scoring must include only primary keys for feature lookups, and external columns are ignored automatically. Option B, external columns like browser are not ignored. They must be explicitly included in the inference data frame to ensure consistent predictions. Option C, the model retrieves all columns, including external ones, from feature store automatically without user input. Option D, the scoring data frame must exclude all columns not defined as lookup keys in the feature tables. All right, take a second, think about it. Which one feels right to you? Don't rush, because this is a really common area where people make mistakes. So here's the deal. Imagine you trained a model using both features stored in the feature store and some extra columns that weren't part of the store, like browser. Now you want to run batch inference using the score batch API. The feature store only retrieves features that are actually registered in it. It doesn't magically know about your external columns. That means if you leave those external columns out of your scoring data frame, your model won't have all the inputs it needs. And guess what happens then? Missing input errors. Or worse, it runs, but your predictions are inconsistent and possibly wrong. Not ideal, right? Imagine you just trained this beautiful model. You use the feature store for most of your features. You've got your nice clean feature tables with user ID and timestamp as the keys. Everything's versioned, life is good. But you also said, you know what, the browser column from the raw clickstream table is actually pretty predictive. So you pulled that in directly during training. Totally normal, happens all the time. Now it's inference time. You've got a fresh batch of data. You want to run score batch at Bifgage, and you're thinking, sweet, the feature store will just magically grab everything I need, right? Yeah, about that. Let's look at this first image on screen. See how the feature store arrow goes straight into the model? That part works perfectly. It will automatically do the lookup for every feature that's actually registered in the store. But look at that lonely little external columns, e.g. browser box hanging out by itself. That column was never registered in the feature store, so score batch has zero clue where to get it from. If you forget to include browser in your inference data frame, what happens? Boom, cryptic error message that makes you want to throw your laptop out the window. Or worse, sometimes it quietly fills with nulls and your predictions silently tank and you don't even realize until the business team starts yelling. Hang on, because this part's super important. The feature store is amazing, but it's not psychic. It only serves features that you explicitly told it to serve. Anything else you use during training, that's on you to bring to the party every single time. Now let's break down the options together. Option B, which says correct answer, and it says external columns must be explicitly included. Ding, 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 this one's correct. You have to provide all the external columns. Option A says you can just include primary keys and the external columns are ignored automatically. Nope, that's not how it works. Excluding external columns that were used in training leads to incomplete features. Your model literally expects those inputs. Option C suggests the model will pull all columns, including external ones, automatically from the feature store. The store only knows about the features registered in it. Anything outside, like browser, you need to provide manually. Option D says you should exclude any columns that aren't lookup keys. Again, not correct. If those external columns were used during training, excluding them breaks your feature set and risks errors or degraded model performance. So, what does this really mean for you? Anytime you train a model using a mix of feature store features and external columns, always include those external columns during batch scoring. Think of the feature store as a smart assistant that knows only part of the story. The rest is still your job to feed in correctly. By keeping this in mind, you'll avoid those tricky missing input errors and make sure your predictions are consistent and reliable. And honestly, once you've done this a few times, it becomes second nature. All right, that wraps up our dive into handling external columns with Databricks Feature Store Batch Inference. If you found this helpful, make sure to like, subscribe, and hit that notification bell so you don't miss future ML tips and walkthroughs. Until next time, keep experimenting and keep learning. Your models will thank you.